Hello and welcome back. Today in module number 2, we're going to start basically the foundation of statistics. We are going to talk about descriptive statistics. In the second part of this lecture, which will be a little bit long than expected, we are going to talk or going to experience how to apply descriptive statistics into RStudio. I'll give you an example. I will post the code into Canvas, and I will also assign you some homework to do. In addition to that, in addition to working with RStudio, I will assign you to do some reading, and that will be schedule for each model that we're going to cover in this class. You're going to do exercise and you're going to do some reading on the subject. Okay, so let's start with the basic, and I said descriptive statistics is the foundation of statistics. It usually defines or classified into two types. The central tendency, what does the central tendency tells us, and what formula we are going to use to measure the central tendency, and the variance, which is what does it include, what is the range, what is the standard deviation, and the quartiles in order for us to calculate that. That will be the foundation of descriptive statistics. So let's start with the basic, the central tendency. We are trying to figure out what is the central tendency of the entire data set, which means that we are going to look at the mean, we are going to look at the median, and we are going to look at the mode. The mean is the most common measure of central tendency. To those who are already panicking and say, oh no, what I have done in selecting this class, the mean will continue appearing and again throughout the semester. Even in inferential statistics or even in more advanced like predictive models, we are going to see the mean as a way for us to calculate the central distribution of the data set, and this is one of the foundation to it. So the formula for that is usually we have a sample size and we add all the observed value, in this case x1, x2 and xn, and we divide that in order for us to do that. In this example below, you see that there's two types of data sets. One is 1 to 5 and the other one is 1 to 10. As you can see, if we will calculate the two means of those two data sets, we will get a different result. By saying that, or by showing that, I intended to show you that the mean is affected by extreme values or outliers. And it is important to understand that because the next calculation or the next formula is the median. And the median is the middle number, 50% above and 50% below. But it does not affect by extreme values. So in this case, as the experience in the previous slide, in this I use the same set, and as you can see, the median will remain the same and it is equal to 3. How do we find the median? This is a little bit more tricky. Why? Because we do not have a straight formula of how to find the median. We can do that, but the formula that we usually find in statistical textbook is n+1 divided by 2, which will only give you the position of the median in the ranking data. So this isn't something that is important for you to do if you are doing it manually. The mode is the value that occurs most often, and it does not affect by extreme value. And it can be either numerical or categorical data, and we will talk about what is the difference between numerical and categorical variables later on. But right now, there might be in a data set that there is no mode, and there might be several modes, and again depends on the data set. Let's see an example. A review of 5 houses on a hill by the beach, and every house has a different price, even though the 2 last houses has the same price. If we will apply descriptive statistics into it, we will learn, for example, that the mean is equal $600,000 and the medium is equal $300,000 and the mode is equal to $10,000. As you can see, each one of them play different role in describing the distribution of this data and what does it tell us. So the mean is usually used at less extreme values. The medium is often used since the medium is not sensitive to extreme value. Example, why are we using it? When the medium home house price may be reported for a region is less sensitive to outlier because there is so much. So this is something that you have to remind yourself. The outlier is usually reported with regard to quartiles. We divided the data set into 4 quartiles. So we have quartile 1, quartile 2, and quartile 3. And those quartile is equal 25% of the observation, and they are smaller than the 75% of the data set. So quartile 2 is the same as the medium, and only 25% of the observation are greater than the third quartiles. So the formula for the quartiles is Q1, quartile 1, equal n plus 1 divided by 4. Quartile 2 is equal n plus 1 divided by 2. Quartile 3 is equal 3 multiplied by n plus 1 divided by 4. N is the number of observed values. So, example, find the first quartile. So what we do here is we have 9 observation, 9 plus 1 divided by 4, and it will give us the 2.5 position. So quartile 1 is equal 12.5. So again, this is where we do it manually and not asking or typing it into OR in order for us to find it. Part 2. We are now going to the second part, and now we are going to talk about range, interrange, variance, standard deviation, and I will try to cover coefficient. I cannot promise you because I still want to cover R. So the idea of variance is the measure of variance giving information on the spread or the versatility of the data values. So we are looking at different set of data, and we are looking at if they have the same central but different values to them. So the range is usually allowed us to calculate the smallest measurement of variance, and it is usually the largest minus the smallest. In this example, 14 is the largest number, 1 is the smallest, and so the range will be equal 13. The disadvantage of the range is that it ignores the way the data are distributed. And this is really important, and that's why we do not often use the range as a way for us to describe the data. So again, this is part of the issue. The interquartile range try to eliminate the problem of range or two outliers by using interquartiles. So it eliminates some high and low value observation and try to calculate the range from the remaining values. So in this case is quartile 3 minus quartile 1 will give us the interquartile. So in this case, if it is quartile 1 is equal 30, quartile 3 is equal 57, so the interquartile it will equal 57 minus 30 is equal 27. Okay, so now we are coming into the the stage of equation. And the first equation that we are going to learn is the variance, where it follows up with the standard deviation. So the variance, basically, it's the average of square deviation of the value of the mean. So in this case, the x of each score, x square is the mean of the average, n is the number of value, and we have the mean that we sum across the value. So let's look at that from perspective of the standard deviation, which is basically the most common way to us to measure. So the sample standard deviation formula stands as follows, and this is how we calculate that. Let's see an example for that. So in this case, we are using the mean, and we are using the n as a way for us to calculate. So in this case, the first value is 10. 10 minus 16. Why 16? Because it is the mean, in this case 10 minus 16, square root plus the next value. So in this case, this is how we do that, and we add everything up and then square it in order for us to get 4.2426 as around the mean, in order for us to say this is the value of the standard deviation. We have, when we're looking at the visual aspect of it, we might have small standard deviation or large standard deviation. And when we are trying to compare standard deviation to different set of values, you can see how the standard deviation has an effect with regard when the mean is equal to all three sets. So in this case, the standard deviation gives you additional value that the mean does not provide. The advantage of the standard deviation, that each value in the data set is used in the calculation. The value far from the mean are giving extra weight. If we're going to talk about a little bit more about coefficient of variance, we need to talk about the measurement of relative variance, and always in percentage, and it shows the relative to the mean, and it can be compared two or more sets to measure in different units. So let's take an example of stock. Stock market is a big issue in how we compare. We have stock A and stock B, and the average price last year was 50, and the average stock of stock B was 100. We calculate the standard deviation and we find both is equal to 5. If we will do coefficient of variance, we will see the difference between them. So again, both stock have the same standard deviation, but stock B is less variable relative to its price because it is only 5% in compared to stock A, which is 10%. Now we need to start talking about the shape of the distribution. And if you remember in high school, or you remember if you took any other class in statistics, when we are talking about the mean, usually we are talking about the shape of distribution. So when the mean is smaller than the median, this is what we should see out of the distribution. When the mean is equal to the median, it will be a straight line, and it will show you exactly where it lay out. So the middle line is the mean, and this is how we show the distribution. I hope you will make sense of it. I hope it makes sense to you. Another thing that I want to repeat again and again is that empirical rule. If the data distribution is a bell shape, then we can say that if we will say that 68% of the data contain the value of the population or the sample, will be a very important rule for us to lay out or to report on. And so the distribution is a part of our job when we are doing descriptive statistics. We can also talk about 95% or 99.7%. And again, this is how we calculate that, and this is how we apply that in order for us to do that. Okay, so this is a very short description of descriptive statistics. Now let's have the fun. And when we are talking about the fun, let's do it in our studio. Okay. So when we are talking about machine languages, we are talking about two types. We are talking about machine learning and assembling learning. And we are talking about the string of numbers giving a machine specific instructions, and assembling language like English with abbreviation, where the computer able to understand what we are writing in order for it to assemble the ability. Example, load, example, add, or example, store the data. You see, I am excited because there is an effect, PowerPoint effect to it, so I added that to make sure that we understand that. So when we are talking about high-level languages, the instructions are very closely related to English. So, example, when we are using a mathematical notation, that example gross pay, which is equal to base pay plus overtime pay, that will give the computer the idea, or the machine ability to understand that in order for it to calculate or to apply that into reality. Some of the high-level languages that you probably heard or hopefully learn, if not, we will skip on that, but it is important to remember that it is the COBOL that started this high-level language in computer science. And that was the foundation of how to manipulate large amount of data. One of those assembles we will see in our packages that try to take formation from COBOL and apply it to data, but again, this is in the next class that I'm teaching about the open source R code and programming aspect. But for now, let's talk about the syntax of the code, because you're going to do that and you're going to run the statistical using R, and you will need to know the syntax in order to apply or to generate a meaningful understanding what does it entail. So all computer programs are collections of instructions. So your R commands will be instructed to the R to provide us interpretation, provide us codes how to read the data in order to produce the result we are looking for. So we have a lot of meaningful units in this syntax. Example, data object. Example, time object. Example, paycheck object or invoice object. Any noun that can represent an object. This is meaningful because we will see that in R and we will learn about that. So it gives us better organized or easier to maintain a procedure in R or any other language. So in R, let you create or store data inside an object. For example, you can save data as an object like A or B. So in example, in this case, if we will say A and we will say, I want you to keep the number 1 as an object, he will do that. So in this case, if we will ask what is the value of A, he will say A. That will give us the ability to manipulate that, because the next line we can say, okay, if A is equal 1, what will be plus 2 equal 2? And again, this is something that the R do so well. unlike Excel that everything has to lay out for you, you have the ability to store information into the R and then refer it back, so you will be able to pull it back or to use it into your calculation. So there is good names and bad names in R. Good names is A, B, or first. Bad names when you're using numerical and text together. Example, the dollar sign, or a square, or hashtag bad. Those are bad names because you will mess up the reader and you messed up the R. So I recommend you to use good names in order for you to use it. And again, you can see the names you have already used by using the command AIS. So IS, and it will show you all the commands that you use in your function. So what is a function? Okay, so a function is a name of selection of a program that performs a specific task. Example, we will learn a function that allowed us to calculate the mean or the standard deviation. Some programming language makes a distinction between a function, which returns a value, and a procedure, which performs some operation. And this is important to understand, because if it's a function, is it to return a value or is it doing some other operation into it? In R, the functions are fundamental, the most important element. So R comes with many functional built-in. So let's say that you are looking for the mean, the calculation of the mean as a function. So in this case, the mean, you will write the mean. You will have a container that will hold some data. Example, in this set is 1, 2, 3, and 4. And it will hold this container, and the function mean will calculate what is the mean for that. And also another function we will learn is standard deviation, or other things that we will learn how to use in order for us to get those calculations. For the full list of all the functions in R, this is a good resources that I highly recommend. I highly recommend the first link, because this is from the R project, which is the foundation of the R. So the data that you pass into the function is called the function arguments. So in computer science, argument is usually associated with the idea of what can we bring into the function and how do we do that. So the argument can be drawn from a raw data, or the R object, or even result from another R function. So example, the mean of 1 and 6, or the functional of the mean of 1 and 6, and as you can see, you can play with that and you have more control. Why I'm saying more control? Because in Excel, when you do that, you do not have full ability to control what you are doing. So in this case, the argument in R is your idea of what you need to do in order for you to achieve your calculation. So in this example, we will use sample. What is a sample? A sample is a collection of data that's selected from statistical population by defined procedure. The elements of the sample are known as sample points, or sample units, or observation. So I add on this function the sample replacement that I marked as true. So what is a replacement? When a sample unit is drawn from defined population, it is returned to that population after its characteristics has been recorded. But after it redraw, we can go back, bring it back to the sample. That's important, because one of the things that we are talking about a sample, if it's a small sample, we like to use all the variables that we selected for the sample and to apply that. I will talk more about that sample in the next module, but again, you're going to read about that and you're going to better understand what it is. So the sample C has the size of 2, replacement is true, and it will give us the result. The function in R is also, we have a function called first class object, which means that they are treated like any other R object. And so the function can pass as argument to other functions. So every function in R has 3 parts: a name, a body, and a set of arguments. So to make your own function, you need to replicate those parts and store that into the R. So the function has to have a name, which potentially can have a default name. A formal argument, the argument include the function definition, and the formal function return a list of all the formal arguments of a function. Not every function called in R makes all the same formal arguments, and this is important to understand. And the function arguments can be misleading or might have default values. Another component of R is the vector. A vector is a sequence of data elements of the same type, basic type. So members in a vector are officially called components, whereas when we are calling them number in this site or in this class or in this book. So here's a vector contain numerical value of 2, 3, and 5. And if we will have them a vector logical value, it will be true or false. So our idea here is that the vector can contain a character as a string. And it means that we can add those values as a true or false. So the idea here is that the number of members in a vector is given by the length of the function. So in this case, this is what it will entail. When we are using logical vector as an index, we are coming into the idea of the indexing or the positioning where the logical vector is true is returned. And so in this case, true, false, false, and true. And in this case, we're going to give it a value. Let's have x is smaller than 0. So we are going to do some filtering to the data based on condition, then is smaller than 0. And what he will turn out to be is -3 and -1. And we can convert it and based on the condition that we are assemble. We also can modify the vector using the assign operator. So in this case, again, see the example that I modified the value of x smaller than 0 or 1 to 4 in order for me to modify the vector values and apply that. We can also doing a deleting vector, which can delete a vector by simply assigning a null to it. So example, if the x is equal to -3, -2, -1, 0, 1, and 2, if we will assign a null to it, it will delete all the values that already in the container, that hold in the container of x. So in this case, it all comes down to it. A list in R is generic vector containing other object. For example, a variable x. X is a list containing copies of 3 vectors of n, s, and b, and a as a numerical values. So in this case, we can apply the true and false into those values and give us the result of it. I lay out the next subject that I need to talk to you about is the import data to R. In this example, I'm talking from my own books is import data using the R terminal and not the R RStudio. In the RStudio, when we are doing the RStudio, we're going to see, hold on, we are going to receive for me the idea what you need to do in order for you to read that. So you have a command, you have the ability to import that, and you see what is it entail. The R also give you the ability to, hold on, just give me 2 seconds. Test, I will call it test class, and I can insert data into it. You can set up a working directory, which I highly recommend, and you will know where it is. You can rename it, and you can import files by using it, and you can build your own configuration tools to it, and you can start tools installing and uploading. I will talk more about that throughout next class when we're going to discuss that. But when we are talking about data set, we can also use one of the things that one of my students showed me. I was surprised to find it. You can do that by just pulling it out. So in this case, I have a data set. Example, I collect the Journal of Ecology. And so what I do here is I'm going to select the folder that I want to. I'm going to import that as the data set, and he will import that to R. So the idea here is quite easy. We can import set, we can upload it, and I'll show you more resource on about how to import data to R using Excel or using other platform such as SPSS. So from Excel, when you do the terminal, this is how the set. But in RStudio, it's quite easy, and I'll show you more example, or I'll give you more example on that. I want to finish our class today with regard to what we cover so far with R and descriptive statistics. Let's have that this is a function, and this function called x, and in this case, the x in this case, I will make it bigger, just give me 2 seconds, zoom in. Okay, so in this case, we have x, and we have a container that is 3, 2, 3, 4, 5, and 6, and when we are telling the R to run it, you can see that the console accepts that and run as it is. He will now associate x with the container that we have. If I will ask the R, for example, to have the medium, to calculate the medium for this container, I will say medium, and the name of the container is x, and I will ask it to calculate, and he will come back to me and say 4. And the same go with the medium, the mode, the standard deviation. You do not spell out the standard deviation, you call it SD, and if you run it, it will calculate that. But one of the things that R is really good at, and this is only the start, we are only in the second class, is the ability to plot things, the ability to visualize things. So if in this case, this is the distribution of the data, it's not normal distribution, and as you can see, we can say summary, and we can say for the R, please summarize this data set, and he will give us what we covered in this class. We covered the minimal value, the first quartile, the third quartile, the mean, the medium, and the max, the largest number in that set. So this is the idea, this is the assignment that you're going to have. You're going to apply all those functions into R. This is going to be your first example. You probably will complain about that and you will say, I don't know how to do that. If you want to export this image as an image, save it as age, save it, know where the position of it, and it will save it to you. That's it for now. I hope it is not too much. I know that I talked a lot, but I hope you enjoyed it, because R is really all about make it easy for us to learn statistics. So until next time, be aware, you're going to have a lot of reading to do about sample, about descriptive statistics, about what is a variables, what is categorical variables. So hold on, you're going to get a lot of reading and a lot of exercise. So just enjoy and try to learn as much as you can. Until next time, have fun. Bye.